Hello everyone, today we start with the Unit 8, the pinch and the grid. The first lesson treats about pinch principle. The pinch is the value of the enthalpy flow in the temperature versus enthalpy diagram where the temperature approach between composite curves is minimum. The pinch has two temperatures, not one, associated. One for the hot composite curve and one for the cold composite curve. The pinch implies difficulties for heat transfer due to the reduced driving force. Or simpler, the closer the two curves, the more difficult it is to transmit heat between them. The fundamental meaning of the pinch is that it marks a division in the set of streams that fall the problem in two. A set of streams or part of streams above the pinch and a set of streams or part of streams below the pinch. Hot streams above the pinch are those with presence at a temperature above the hot pinch temperature, and cold streams above the pinch are those streams or part of streams with presence above the cold pinch temperature, and the equivalent below the pinch. Then they are the hot and cold pinch temperature which mark the division. The pinch principle established that one pinch splits the problem in two semi-problems. A hot semi-problem above the pinch that receives high-grade enthalpy from battery limits, this is hot utility, and doesn't leave enthalpy flow below the pinch. And a cold semi-problem below the pinch, where no enthalpy flow arrives from battery limits, and it sends a low-grade enthalpy flow towards battery limits through the cold utility. The hot semi-problem acts as a sink for enthalpy, while the cold semi-problem acts as a source of enthalpy. This disposition has a consequence. As the energy balance has to be met for any semi-problem, if some heat is transferred across the pinch, then more heat utility, more enthalpy flow from battery limits will be needed in the hot semi-problem, and more enthalpy flow will be needed in the cold semi-problem. What gives us a guide, a design method. We must transfer no heat across the pinch, and then utilities will rest at its minima. And what means exactly to transfer heat across the pinch? Matching in a thermal contact a stream above the pinch with a stream below the pinch. Specifically, a hot stream above the pinch with a cold stream below the pinch. The other way is not possible. And as particular cases, not using hot utility below the pinch, nor cold utility above the pinch. Why? Because hot utility is a hot stream above the pinch, and cold utility is a cold stream below the pinch. These laws will guide our minimum network design.